In this video, we're going to be taking a look at investigation 5, more specifically problem 5.1, stopping Sneaky Sally. Now, we have looked at the Pythagorean theorem. This entire unit has been all about leading up to the Pythagorean theorem and how it's used. It's a huge importance in the mathematical community to solve real-life problems. And today, we're going to be looking at baseball. And Sneaky Sally is actually trying to steal bases. So we're going to use the Pythagorean theorem to find the distances between different bases. So yeah, I know everybody knows the distance between home plate and first and second, but what about the distance from home plate to the pitcher's mound, or the distance between home plate and second base, or first base to third base, pitcher's mound to third base, and so forth? We're going to be looking at all of those distances today in problem 5.1. So let's understand what's going on. Horace Hanson is the catcher for the Humboldt Bees baseball team. Sneaky Sally Smith, the star of the Canfield Cats, is on first base. Sally is known for stealing base. That's why she's called Sneaky Sally. So Horace is keeping an eye on her. The pitcher throws a fastball and the batter swings and misses. Horace catches the pitch, and out of the corner of his eye, he sees Sally take off for second base. Use the diagram to answer questions A through C. So here's our diagram. And I believe you also have a lab sheet for this that looks like this. You are welcome to work out some of these problems on this lab sheets, as long as when it asks you to explain, that you explain. So the first one says, how far must Horace throw the ball to get Sally out at second? So the first one is answering the question, how far is it from home to second? And then part 2 says, Jen says the distance that Horace throws the baseball is a rational number. Funda says it's irrational. Explain each student's reasoning. So go ahead and answer part A, 1, and 2, and then come back to the video. So for part A, number 1, we got to find this distance here. And so we know that the distance from home plate to first, that's 90 feet. And then from first to second, that also is 90 feet. So we have that right triangle. And so to find the red, it would be 90 squared plus 90 squared is equal to, let's say that's D. So let's say that's the distance of D. So it's equal to D squared. So when we work all of this out, it's going to end up being that D is the square root of 90 squared plus 90 squared. Now you have to take 90 squared plus 90 squared and then take the square root, because when you take 90 squared plus 90 squared, that's equal to 16,200. And so you would find the square root of that, which is 127.828 feet. So that is that distance in red there from the home plate to second base. Now, let's answer part 2, where Jen says, hey, it's a rational number. Funda says it's an irrational number. In a sense, they are both correct, and here's why. Mathematically, that is an irrational number. So that distance is an irrational number. The exact distance is an irrational number. However, since we are incapable of writing down, let alone measuring, an irrational number, we have to approximate. So if you're creating or designing or making this field, right, you would not be able to make the distance equal to 16,200, the square root of that. You would have to make the distance something like maybe 127.25 feet, right? You would have to round to the closest thing that you could actually measure to, because tape measures can go up to 1/4 of an inch, or actually 1/16 of an inch, but this would be a good approximation to 1/4 of an inch. So they're both correct for that reason. Make sure you write down your answer in your notes and then come back to the video for parts B and C. Part B says the shortstop is standing on the baseline halfway between second base and third base. So the shortstop is standing right here, We'll put an X where that shortstop is. It's exactly halfway between second and third. How far is the shortstop from Horace? So remember, Horace is at home plate. So we want to know the distance from there to there. And now we have another right triangle, a bit different than the one we've been working on. But go ahead and find that distance and then come back to the video to see how you did. All right, so now instead of this being 90 feet, this across here is 45 feet. This is still 90 feet. And we don't know what this is. So let's just say that this is a distance of D. Okay. We do know that this is a right triangle. That's a right angle there. And so we can set up for our Pythagorean theorem. So that'd be 45 squared plus 90 squared is equal to D squared. You can take 45 squared plus 90 squared and then take the square root of that. So whatever this is, 45 squared plus 90 squared, you would put that into your calculator first and then take the square root of that, and you should get the distance is equal to 100.62 feet. That's that distance right there. Part C says the pitcher's mound is 60 feet 6 inches from home plate. So that's this distance right here. So the pitcher's mound right here, that's 60.5 feet from home plate. Use this information and your answer to question A to find the distance from the pitcher's mound to each base. Now here's the tricky part. The pitcher's mound is not halfway between home plate and second base. Right, because we know that the distance between home plate and second base was 127.28 feet. Let's round it to 0.24 feet. That's fine. Right, and if we find half distance, that gives us 63.63 feet. Okay, so if the pitcher's mound was halfway, it would be at 63.63 feet, but it's not. So it's just before halfway. So this distance here is actually shorter than this distance here. Okay, so now what we're going to do is we're going to find the distances from the pitcher's mound to first and third base, and then to second base. Now, let's first of all figure out to second base, because that's going to be the easiest. Go ahead on your own, figure out what is the distance between the pitcher's mound and second base, and then come back to the video to check your answer. All right, so to figure out what it is to second base, we know from home plate to second is 127.24. Then home plate to the pitcher's mound is 60.5, because 6 inches is half foot, so that's why it's 60.5. And so we're going to go ahead and subtract those. And I forgot, this was a 4. I changed it to a 5 because it is point. We rounded to the 1/4. And so when we get that, subtract those, you end up with 66 3/4, so 66.75 feet. So that's the distance from home plate, the pitcher's mound to second base. Label that in your notes as the distance from the pitcher's mound to second base. Now let's take a look from the pitcher's mound to first base. I want you to try to set this up, to try to think about this on your own, because it's not as simple as just drawing a right triangle. The problem is, you kind of see it, since this is not exactly halfway, you can't draw a right angle. So this is not a right angle in there. So what we have to do is we have to set it up using a triangle, but our triangle is going to look a little bit differently, because since we're not halfway, we have to draw our triangle to halfway. So let's say this is halfway. So we draw the base of our triangle there. Then when we draw this line straight over, that creates a right angle there. And then we have our hypotenuse. And it's our hypotenuse that is the side that we're trying to find. So this one I'll do a different color. That's the one we're going to try to find, because from the pitcher's mound, that's where he's throwing it. So that's what we're looking for there. So now that you have this all set up, let me get rid of this information around here. Now that you have this triangle set up, try to figure out what those measurements would be, and then try to solve for that hypotenuse, which would be the distance the pitcher would throw it to first base, and then come back to the video to see how you did. Now, if you haven't tried this, make sure you try it on your own. Okay? Now, here, we know a couple of these distances. We know that what the distance from halfway to first base is going to be. We've already figured that out. And that was over here. That was 63.63. So this distance is going to be 3.63 feet. And then this distance here is going to be a little bit trickier. But we know that, hey, this is halfway and this is where the pitcher's mound is. So we can just subtract those two, right? Where do we find the pitcher's mound? So yeah, we would subtract these two to get, I got 3.14. So this is 3.14 feet. Now we have a right triangle and we know the two legs, so let's set up our Pythagorean theorem. So you'd have 63.63 squared plus 3.14 squared is equal to, if we say this is d, that's equal to d squared. And so d squared is going to be the square root of 63.63 squared plus 3.14 squared. That gives us our distance. And so we should have a distance of about 63. So I'm going to write this 63.72 or 73 feet. So you notice it's almost equal to halfway, but since he's 3 feet away from halfway, it's going to be just a little bit further, like 1/4 of a foot further. Not much further, but a little bit further for him to throw it. And then for third base, it's just reflective symmetry. So third base is going to be the same. So this is from the pitcher's mound to both first and third base. Would be that 63.75 of a foot, approximately 3/4 of a foot. Okay, so make sure you clearly have all of these distances from the pitcher's mound to second, first, third, and then home base. So pitcher's mound to first and third will be the same, but pitcher's mound to second will be different than the pitcher's mound to home plate. Okay, so that answers question C. And this is pretty interesting down here if you read this. Consider the baseball an American invention. Most people do. A similar game called rounders, however, was played in England as early as 1600s. Like baseball, rounders involved hitting the ball and running around bases. However, in rounders, the fielders actually threw the ball at the base runners. That would make things a lot more interesting. If a ball hit a runner while he was off the base, he was out. The original dodgeball right there. When men were men and women were women, and they weren't crying when they got hit in the face with a baseball. Alexander Cartwright was a founding member of the Knickerbockers Baseball Club of New York City, baseball's first organized club. Cartwright played a key role in writing the first set of formal rules for baseball in 1845. According to Cartwright's rules, a batter was out if a fielder caught the ball either on the fly or on the first bounce. Today, balls caught on the first bounce are not out. That's also very interesting. Cartwright's rules also say that the first team to have 21 runs at the end of an inning, wow, was the winner today. The team with the highest score after 9 innings wins the game. So what do you think? Are these good addition rules changes to the original game of rounders? Do you think we should still be throwing balls at each other instead of catching them in gloves? Do you think it should be an out if you catch it on the first bounce? Anyway, I just thought that was very interesting. That is all that I have for 5.1, Stopping Sneaky Sally.